SpaceX and Tesla just dropped one of the most ambitious manufacturing announcements in tech history, TERAFAB. The goal is to produce over a terawatt of compute per year, spanning logic chips, memory, and advanced packaging. This isn't a data center expansion or a cloud upgrade. This is a vertically integrated bet that the future of AI is won at the silicon layer, not the software layer. Every major AI lab right now is hitting the same invisible ceiling: compute. Training runs get queued for weeks. Inference capacity throttles product launches before they even reach users. OpenAI, Google DeepMind, Anthropic, they're all racing to secure GPU allocations the way airlines fight for runway slots. Musk's thesis with TeraFab is that the company that manufactures its own compute supply chain doesn't just compete, it dictates the pace of the entire industry. Here's the detail that separates TeraFab from every other big compute announcement. Roughly 80% of its output is destined for space, with only 20% for ground infrastructure. Starlink has already proven that distributed compute at orbital scale is operationally viable. Moving AI workloads off-planet fundamentally rewrites the physics playbook. Heat dissipation in the vacuum of space is radically different. And access to solar power without atmospheric loss changes the economics of running massive models entirely. What truly differentiates TeraFab from AWS spinning up another GPU cluster is the depth of vertical integration behind it. Tesla builds its own Dojo chips and designs its own supercomputer infrastructure. SpaceX manufactures rockets, satellites, and ground hardware in-house. Combining that manufacturing DNA with a chip fabrication strategy creates an entity that controls inputs at every layer of the stack, something no hyperscaler has ever achieved. Amazon and Microsoft rent compute. SpaceX and Tesla want to own the means of production. Let's be honest about the skeptic case, because it's a serious one. TSMC, the most advanced chip manufacturer on the planet, measured its entire 2024 output in hundreds of billions of transistors per wafer, not terawatts of delivered compute. Musk has a history of announcing manufacturing targets that slip by years. The Cybertruck, full self-driving timelines, Mars missions. The distance between a terawatt announcement and a terawatt of actual silicon is measured in billions of dollars and years of execution risk. Here's the critical insight that gets lost in the hype versus skepticism debate. TeraFab doesn't need to hit its full target to matter enormously. Even at 20% of stated capacity, it would represent a compute supply injection that could meaningfully shift training and inference cost curves across the entire industry. When a new large-scale compute source enters the market, pricing models break down. The companies and engineers building on today's cost assumptions could find their financial projections are obsolete within 3 years. The deeper strategic signal in TeraFab is a philosophical shift in how the compute problem gets framed. Until now, even the biggest AI labs approached compute as a procurement challenge. Negotiate better GPU contracts, diversify cloud providers, optimize utilization rates. TeraFab reframes it as a first principles manufacturing problem, the same way SpaceX reframed rocket launches and Tesla reframed car production. That mental model shift alone is more disruptive than any specific capacity number in the announcement. For AI engineers, infrastructure builders, and anyone betting their career on where compute is heading, the space compute angle of TeraFab deserves serious, sustained attention. Orbital AI inference, distributed satellite-based training clusters, power cost economics that ground-based data centers can never match. These aren't speculative futures. They're engineering problems being actively solved right now. The companies and developers who understand this transition early will have a structural advantage that compounds over the next decade.